introduction. And I'm really pleased to make this presentation or to make this talk. It's not just a breakthrough research result which I'm doing now, but it's a kind of review which might be helpful. Roughly, I will talk about background, just current findings and understanding in the East African Rift, facts and figures, some basic and applied science, some challenges and opportunities like science capacity building and outreach. So I'll go straight to the introduction or background. Ever since Gregory coined the Great Rift Valley to the Eastern Branch in 1896, a lot of curiosity has been attracted to the East African Rift. So roughly, the length is from the Dead Sea to the Mozambique. Some people put it like 8,000 kilometers or sometimes 6,000 kilometers. Anyways, the center of attention is from the Afar Depression, which is a matured nascent rift, to the Okavango Delta, which is almost a young rift in the making. My focus will be on seismicity, related with seismicity only. I will not go deep into the deeper studies like, it's not real tomography or geodynamics and other deeper studies in geophysics, but only seismicity related. So the maps that you see here,
we see only the first slide now.
Yes.
This is what I see, at least.
And you have to click.
Yes.
Okay, I have to click. Okay, that's not good. So you are not seeing anything?
No, you need to.
On the first slide.
Yeah, click.
Yeah, I did. I click. Huh?
Sorry. Hello. I don't think
Hello?
it's in a slideshow mode. It's just
We know Daniel. We know Daniel, but
okay, now it works. Well,
okay.
Yes, you need to move with your mouse.
Okay, in that case, I just move with my mouse. So
thanks. Go ahead.
I'm here in the introduction. So in the background, I start with this morphology of the East African Rift, where Gregory suggested a Great Rift Valley for the Eastern Branch in 1986. So ever since this acronym was coined for that part of the rift, it's just attracted a lot of earth scientists. So I think it's visible now. The one that you see on the left panel is a seismicity map produced by Seiberg in 1932, I think, from macroseismic data collected from missionaries in the East African region, So the white one is rare or unknown, and the next darker one, a little bit darker one, is moderately frequent but not violent. Then the next darker is frequent and occasionally destructive. And the last, the more darker one, is world-shaking shocks. Probably this is a 1910 Tanzanian earthquake, the Subuka Valley earthquake, and the 1906 6-point magnitude earthquake in the Ethiopian Rift. So in those days, almost there was no match station in Africa, maybe Helwan in the north and the Cape of Good Hope in South Africa and some others. But instrumentation was not really that great. So those large magnitude earthquakes were mostly observed from other stations elsewhere, mostly in Europe. So this seismicity on the left panel, for instance, is mostly reported from Gutenberg and Richter 1954, and Sykes and Landisman. So they used records from Wichart's records, and for instance, this is seismicity. This is a bulletin reported from Hamburg station for the Subuka Valley earthquake in Kenya. So they collected this kind of data and somehow concluded the seismicity of the East African Rift. But later on, when instrumentation was expanding, the seismicity of the East African Rift was improving a little bit. The one on the left panel, for instance, is from NIC catalog from 1973 to the 1910, I guess, thereabout. The one on the right panel is from Craig's work. And in general, we infer that magmatism decreases when we go from the Afar region to the Kavango Delta. Spreading rate also decreases when you go to the southwest, and earthquake depths and magnitude also increases. So these are the features and current understandings. When we see the IDC from Vienna, for instance, all the plate boundaries are well marked, but the East African region looks as seismic, but that's not the case. It's really seismically active, but it's because of sparse station coverage and lack of capacity and expertise and poor documentation and the likes. The mode of deformation mostly being an active rift, it's the extensional deformation, but sometimes you may find thrust faulting in the making, for instance, the Congo region, from a published work in 2000 from Ayele, published in Journal of African Earth Science. So it was consistently thrust faulting. Otherwise, the whole East African rift is almost dominated by normal faults. Then when instrumentation is really improving, and thanks to broadband seismology, quite a number of permanent stations are working in Africa, and also some temporary projects were successfully conducted in the East African rift. So we managed to capture and characterize like the 2005 megadike intrusion in the Afar, the Nyiragongo eruption in 2002, the Matches earthquake in 2006, and the Karonga earthquake and the Natron volcanotectonic activity in Tanzania, and also the Nabro eruption in 2011 in Eritrea. So these were really main features thanks to modern seismology that we managed to monitor what's going on in our continent. And this small dice also shows that the red one is significant part of the deformation is due to magmatic feature, and the other one is tectonic type. So when we go from the Afar region to the south, magmatism decreases, as we said earlier. If we come to the Ethiopian case, for instance, we have managed to capture a lot of activities since 2000, for instance, thanks to modern seismology again. And we managed to communicate this observation to our overseas collaborators. They came with state-of-the-art, broadband seismology, GPS INSAR, so a lot of interesting results were achieved, and we managed to understand the East African rift better. This shows the back 2006 model, which is a magma-assisted rifting, which is the most plausible one to be accepted currently. And the next slide shows the, just a bit of deeper studies from tomography that there is some Chiro anomaly in the Afar region, dominantly in both cross sections when we go from the southwest to the northeast, and also from the Hagar to the Afar. So Afar is really a center of attention in that case. If we really run a broadband station in our region, we can find a bunch of activities like microfractures, volcanotectonic events, low frequency events, very low frequency ones, ultra long periods, and tilt. So broadband seismology is really very useful in our region for volcanoseismology. Especially the Afar is where the most of the active volcanoes are hosted, and also dike intrusions. And the Atalay is the most active magma lake, which is still existing almost, I don't know, since some geologic past. This map shows the different activities. Even when I came back after my PhD, a lot of activities that we captured in the Afar are always in the kind of cluster type where magmatic activities always dominating. Especially the 2005 one was the one which was really significant in terms of overseas collaboration. There was no much stations at that time, but from what was available in Ethiopia, in Yemen, in Djibouti, and Eritrea, one Nature paper was published by Team Wright, and another one, me as the first author in 2007. where we thought that the dike started from the north, but later with more data coming from the countries that I mentioned, like from Asmara, Djibouti, and Yemen, we managed to locate the source of the dike in the middle of the segment. And strangely, unusual low frequency, rumbling is always following the seismic signal, which is indicative of some magmatic activity in the region. So this was the work contributed by myself and other colleagues. So it was published in JRL. So we managed to conclude that in fact the mega dike source was in the middle of the Addis volcanic complex instead of Boina, which we originally thought. So volcanoseismology is really a very good science to study in the Afar, and this is, for instance, seismicity that shows dike and some volcanic activity in the Afar region. But thanks to collaborations, if you really deploy very dense station network, you can really do very beautiful science. This is just the dike intrusion from Ebinger 2010. So, but it needs very strong and committed international collaboration. In Africa in general, it was really a challenge to observe whatever activity we have and locate events. This is, for instance, single station location from fully station only using DMAS software, which we use to run. For instance, this one is a teleseismic event from Ryukyu Island in Japan. And our location, maybe it's by coincidence from a single station, it's very difficult to pinpoint the right epicenter. And we also managed to characterize some regional activities using single station. That was the one we used to run that time. But recently we managed to, for instance, I'm talking about the Ethiopian case, to develop earthworm system where we can pull data from the Ethiopian network here, which is black, and the blue one is from Mbarara, Uganda, ATD is from Djibouti, Kimbo is from Kenya, Lodwa is also from Kenya, and Ryan from Saudi Arabia. So literally, we generate this helicorridor almost every day in our laboratory, and we manage to monitor what's going on in the Horn of Africa region. So with this technique, we managed to analyze events even in other parts of the East African Rift. For instance, this is an earthquake that occurred in close to the equator of South Pole, I think. No, South Pole, 10.3 S. No, latitude is minus 1.72 degree north, and latitude is 30. That's almost close to the equator. So if earthquakes occur in that part of the region where there is a stable Tanzanian craton, you can capture very clear PNDS waveforms. But if events occur in the Afar region, it's very difficult to pick PNDS arrivals, and it's really a challenge because of the attenuation due to the low velocity anomalies. So we carry on with that kind of culture, and recently we had a workshop in Uganda. This is the Ethiopian contribution, for instance, the one that you see on the right panel, which shows a lot of events from the Afar region to the Albert Rift here, and it's quite encouraging, though it's not perfect. Even in 2021, May 25, we managed also to capture the Nyaragongo activity from the Mbarara station. We also get data from Mbarara station. So if there is a very good center in our region, in addition to the international data centers like USGS or IDC, for instance, in Vienna, we can really characterize the seismic activity and volcanic activity in our region. This is, for instance, the recent workshops that we had in Uganda from October 3 to 7. I have to comment a bit about this. There is a group called Eastern and Southern Africa Regional Seismological Working Group, which is a long name. So these are a composite of 9 countries from Eritrea to Mozambique. So once in a while we come together with our readings and merge together data using SEISAN and then produce bulletins of our group. So if I have to explain this map specifically, the red dots are the PDE, preliminary event determination of epicenter from USGS. The black ones are our reports. So these points, be it black or red or whatever, these are actual events, actual earthquakes that occurred in the East African Rift. They are not wiggles, they are not artifacts. So if we were to have a very good network in the region, you can imagine how best we can locate it. So one can say that really the East African Rift is more active than we believe it is. Same seismicity map on the left panel, and the one on the right one is the station distribution. I'm not sure if it is visible, but they are very sparse station distribution. On a similar argument, this is a published work. My PhD student published this work on the Journal of African Earth Science some years back. I think that's in 2021. So he was comparing for the time 2013 to 2016. So the one on the left panel is the ICC compilation. The one on the right one is the compilation made by the SRSWAG catalog. So you can see that this, I mean, every spot that, as I commented earlier, all these red dots are not really artifacts, but they are actual natural events that occurred in the East African Rift. So if we were to have a better station distribution, a better capacity like the crystal structure, whatever magnitude, all these things, of course we do it the state-of-the-art way, but if we were to have more stations, we could have come up with more detailed features, and we could have characterized the East African Rift better. So the conclusion here is, you know, only from the PDA of the USGS and from the ICC compilation, one would say that the East African Rift is not seismically active, but that's not the case, as we can infer from this figure. When we come to hazard, you see these red dots distributed along the East African Rift are earthquake magnitudes of 6.8 and above. Now, almost urbanization in every country is booming. If our, you know, houses were just like this Tukulu house where our ancestors used to live, you know, nature would have been friendly, but that's not the case. Now, skyscrapers, multi-story buildings are really rising everywhere in the East African Rift with less awareness. So it's really scary. The chance of this 6.8 and above earthquake of repeating itself it's a matter of time, like we have noticed recently in the Maches earthquake in Mozambique. It can happen anytime. So if that happens, our awareness and rapid response scheme in the region is very poor, and it's really very scary. This table shows some of the significant earthquakes that occurred in the region, but only earthquakes that had been reported to have a huge number of casualties were the Toro earthquake in Uganda, which is 6.1 magnitude, and it occurred in 1966. So the casualties were about 150 deaths. So that's really, we feel that this seismologist repeating this size of earthquakes in the region is possible, but the preparation or the preparedness of disaster mitigation is very poor. All governments almost in the region, earthquake and volcanic eruption is not a priority. Probably drought and flood or fire maybe. So it's a bit worrisome. If we talk to even engineers or, you know, people that really undermine the potential damages, but from what have been reported so far, This is a Karonga event of 2009, 6.2. It devastated the Karonga village, part of it actually, a lot of damage. This is the Goma, part of Goma city, I think from 2002 probably. This one is the Kagera in Tanzania, a lot of devastation. And this one is the 1969 Sordo damage in Ethiopia, in Afar, 6.3. Now, with almost 20-kilometer air distance from that Sordo location, there is a booming city called Samara, and even multi-story buildings are in the making, which is really scary. When it comes to capacity building efforts, in addition to what we get from other, North-South collaborations, we also train ourselves with South-South collaboration. So this picture that we see here, we had analyst workshop in 2005 held in Bulawayo, Zimbabwe. So once in a while, we train ourselves with resource persons from the countries around the SARSWAG members. So this group here, for instance, the one on the right is Gabriel Mulibo from Tanzania. Now he is a seasoned seismologist. I remember very well that in that workshop, he was just starting the ABCD of P and S waves. Now he's well-trained seismologist who did his PhD in Penn State, USA. Again, also, we had another workshop in Addis with Tim Ahern from IRIS as the main resource person. And these are just samples. Otherwise, we held training workshops here and there. I think we had many of them also later on. So to conclude, the East African Rift is more active than previously believed, which makes it a well-set natural lab for active rift studies. Because of that, we have a lot of overseas collaborations. It is a little bit slow and passive at the moment because of COVID, but we benefited from that overseas collaboration, for capacity building, training, and publishing and the likes. It's also potential for earthquake and volcanic risk in the East African Rift system is overlooked, which needs attention, as I tried to explain before. Capacity building in equipment and trained manpower should be given prime importance by all the concerned. So I always attest to that for our research collaborators overseas. If you invest in capacity building, somehow in one way or another, you'll get it back. So please try to help us in instrumentation and capacity building. Rift evolution in the East African Rift system, they complement each other, basic science research and disaster risk mitigation. We as Africans here, we can facilitate things on the ground for the purpose of mitigating earthquake and volcanic hazard, and also our overseas collaborators also for the basic science research. So I think that this can be improved a bit better so that we can benefit together. I would like to acknowledge the International Science Program of Uppsala University, which financially supports SARSWAG and also the Ethiopian node. They also help us to procure new equipment and also some training and the likes. So with this, I conclude. The last one is just the pictures of the 2009 workshop at ICTP, where the ICTP was engaged to launch a PhD program, which was somehow failed, but that idea is still should be really in the making. And what I would like to remark at the end is that this is not agriculture that you should build capacity in every district in Africa, but if you build really somehow a seismological network in the region or in the continent, it needs a little effort to monitor our environment. But the problem is it's very difficult to maintain trained staff, to maintain equipment on the ground. But I believe that with a little effort, with some initiative by the African Union or any other concerned body, this activity can be maintained to safeguard property and human life. With that, I finish my presentation. Thank you for your attention.
Well, thank you very much, Atalay, for your presentation. Is there any question? raise your hand. Yeah, Alik, you can unmute yourself and ask your question.
Oh, well, thank you very much. Actually, it was not my intention to have a first question, just to applaud for the talk. It was a lot of information which you gave, but I have a definitely question I will ask. What a puzzle to me, really, it is a slide 31 of yours with a table where you show the very high magnitude events and no casualty. It is a fantastic, but what is the reason actually for that? It's epicenters were located, it's quite far from the place where real settlements are, or their calculation of magnitude wasn't improper, or what is the reason for that? Because even some magnitude, let's say 6 to 7, you know, in such a well-developed country like Italy, generates much more higher casualties and loss of lives. And here we see that only one event, 6-1, but the all other events, no damage, no death. What means, yeah, in this case? This is
thank you, Alik. It's a nice comment, nice remark. You know, the most likely reasons, you know, this table was just filled like that. In a report that I got, either there are two potential, I mean, answers for this question. One is either because they happen in the jungle and no damage in the real sense, or maybe, you know, that time population in Africa was very sparse, and maybe even the damage is not reported at all. You know, communication was very difficult, even if some people might have died. No telephone, no communication. You know, for instance, 1906, no one would know if someone has died somewhere in the jungle because of earthquake. In 1910, Ruku earthquake, the same. But by some means possible, the Toro earthquake that occurred in Uganda the casualties were nicely reported. So my answer is either truly there was no damage because it happened in the jungle, or the damage was not properly reported.
Yes, thank you very much. Another question is related to the buildings which you showed. It's and the question is, how well is a seismic, or let's say, microseismic investigations occur before such a buildings are in place? I mean, it's started to erect.
The building I showed you is a building being constructed in Addis. Now it's I think that building is commissioned, and it is hosting a lot of activities there. And so I think the third generation of building map is already in action in Ethiopia, but macroseismic, I mean, they use from geotechnical investigation of engineers and site effect and you know, rock level hazard values implemented. You know, mostly really the engineers really underestimate things, and I always tell to my engineer colleagues, your profession would be tested when an earthquake comes to Addis. So simply people mold their structures as they wish, and I can't say that it's really constructed up to the standard.
Yeah, I see. It's if it's allowed, it's the last question. It's related to different topics. Did somebody in your institute
Did I answer your question, Ali?
Yeah, in general, yes, yeah, definitely, yeah. But it's most important. It's really to use a proper way to go for safety. You know, it's because it's a country, and definitely it's to benefit from all other issues. I mean, I understand that it's a country is not so. You know, healthy in terms of finance as, let's say, Japan, but still it is possible to use this knowledge and so on to this. But it's another type of question. It's did you or I mean your group somebody compare the seismicity with the heat flux? I mean, it's not just the mapping of two fields, but the looking of the distribution of the magnitudes and the let's say there is heat flux magnitudes.
Yeah, thank you, Alec. I think I lost the last bit of your comment for the previous question, but for the heat flux and seismicity comparison, I don't know, as far as I know. Some people in GEO or GEO meeting, I heard that some people are working on heat flux, but in Ethiopia, as far as I know, there is no one working on that.
Even the area of volcanology also, they don't do it. Yeah?
Not really. No, maybe I don't know. I don't remember anyone working on that.
Okay. Thank you very much. Great. Yeah. Thank you. There are many
Thank
other
you.
people. Yeah.
Okay, so we have Professor Audia, Karim wanted to ask.
Thank you very much. Thanks, Atalay. That was an inspiring talk. I mean, it's always nice to listen to you. So myself, I've been consuming the seismology in Africa for quite some time, but I have just two very simple questions. I'm not very much well educated about the earthquake engineering community. Is there any organized community in Africa? And the second question regards a little bit what has happened with Africa Array? Is it still active? I mean, how is it going? I mean, is there a service that is provided by those stations that are still available in Africa? I will have to leave in a few minutes. I'm sorry for this, but
Yeah.
thank you very much.
Yeah, thank you, Karim. For the engineering community, I don't know if there is a cross-country association as such in, between countries in Africa, but there is association in Ethiopia of engineers. But their interaction with seismologists and geophysics is not that much. But we involve in code revision and the likes. Only few of them were involved, to interact with us. So there is engineering association in Ethiopia. For your second question, Africa Array is not in full gear as it used to be, but I think they're still there. But their focus is not really on hazard mitigation and the likes, but they trained a lot of people, and most of the works done were in deeper investigation, like receiver function, shrivel splitting and the likes. And in fact, also they published hazard map, but I think they are not in good shape at the moment to carry out, disaster risk management in the region.
Okay, thank you very much, Atalay, for your response. We have another hand raised by Jean Damour. Please unmute yourself and ask your question.
Okay, thank you very much. Do you hear me?
Yes, I do.
Yes, we do.
Okay, thank you for the presentation. So it is very informative for African side, but I have like one question. The first one is a supporting idea about the strengthening our African personnel and the networks, but I have a question about how now the center is that we have here in Rwanda. How is it being involved into the increasing the personnel in the seismology? Seeing that here in East Africa we are, let's say, we are suffering from the eruptions of Nyiragongo that is very active, and sometimes the mitigation and the procedures or measures that have been taken are missing the leaders in that sector. So I would be happy to have, let's say, a plan for the contribution from the center to strengthen the personnel into this region, so that we really have a good knowledge about the mitigation related to earthquakes, and seeing we have also the active volcano.
Oh yeah, if I understand your question correctly, I think the center in Rwanda, to start with, Rwanda and Congo should have been, DRC should be really part of our group, but still this is assisted by Uppsala. One day this assistance will go away. That's really what the main major comments that I wanted to put across. The center in Rwanda, for instance, they could have even started to be an analysis center, because there are stations in Africa, even some of the seismic stations are really from IRIS USGS or from some stations in Europe like Geophone or Geoscope in France, in Germany, in IDC, whatever. You can pull all this data, have a strong group there, analyze data, and broadcast results for the end users in the region. So that's what we are lacking, and that's what I wanted to emphasize. This is not like agriculture, which should have been strengthened in every district in any country, for instance. But one center can serve even the East Africa region if it is strong enough. So that's what we are lacking, and I think it would be good if Rwanda and DRC also can join us, so that at least until we have this this ideal center established, we can pull up data, analyze together, and build capacity in the region. Yeah. Did my comment make sense?
Yeah, sure, I got it.
Yeah.
Do you want to add something, Jean d'Amour? No. Okay.
No, it's okay. It's okay. I go to the answers. Maybe from your side, as from the ICTP here in Rwanda, you can maybe see if we can collaborate with that and maybe get improved and involved in that field. Thank you.
Okay, thank you, Jean d'Amour. Alik has another question.
Yes, I have a question about the international cooperation. And Atalay, I know you are very well involved in the IASPE and in the work of this international group and so on. At the same time, there are several international groupings in Africa. One of them, for example, is the African Seismological Commission. Another, it is a more, let's say, science promotion. I mean, it's a seismology promotion in Africa. Another are more scientific in terms of what they are doing. It is one of them. It is a UNESCO project, which is I think it is headed by Mustafa Magroi. Yes, about the seismic hazard investigations. Another one, it is a more social science project related to disaster science, including to the seismic risk, and others, GEO risk, which is a Peri-Peri-U. Aliza, I forgot her name. She's a social scientist from South Africa. And this is a really two very important projects. From one hand, they are dealing with scientific more closely to you seismic hazards. Another hand, it is what is important is seismic risk, because it's even the many earthquakes are moderate earthquakes in Africa, but still you listed just some of them even higher than magnitude 7. And that's quite important to understand if they happen, what could happen in terms of not only the physical vulnerability when the building will collapse, but also social vulnerability, let's say. How much Ethiopia and your institution are involved in these projects? And would you like to extend really your cooperation with this African network?
Alik, I think I get lost with the connection. I didn't catch up quite the information at the beginning, but you did mention that the IGCP project, which Mustafa was heading.
Correct.
We have produced, one of them, IGCP 601. I think we produced the seismotectonic map of Africa, which was really useful. But now, as I was informed from Mustafa recently, we met in Hurghada in Egypt. Is almost about phasing out, so that if somebody might be interested to carry on, he suggested that. And the African Seismological Commission is just you know, it aggravates the science, but there's no much funding. Even we're struggling to have the annual assemblies. So, but what I was trying to put across in this remark was that there is no really such a devoted organization. The group that I mentioned is being assisted by Uppsala University ICP, but the problem is you can't maintain trained manpower. People will go for a green pasture, and CTBT is one consumer, and they go elsewhere. So it's really difficult to maintain the capacity. Some of the stations might be vandalized somewhere in Kenya or in Mozambique, for instance. It's really a challenge. But what I can tell you is that with all urbanization and construction industry is booming in the region, and basic science research is becoming interesting, there is a huge gap to bridge this void and galvanize science, and really doesn't require much really funding. Just quite a sizable funding can really sustain this capacity, and we can move on. So IGCP is, I'm not sure what the current trend is, but it seems that it's not in full gear at the moment. I don't know if I answered your question.
Yes, correct. It's actually it's a very good remark. It's not always the money, it's the driving, you know, scientific progress. Definitely finance, science financing. It's very important, especially for Africa. That's why my point was it's how much this collaboration is really working, especially the linking these countries to countries in Africa, because 50 countries is really big and so on, and continent. This is really important to come to the understanding of the, you know, the in major, not just a separate, but it's looking to Africa as a global view, as a holistic way to understand this, you know, seismicity, volcanology, and I mean volcanic activities and others in the region as a big. Thank you very much for your comments and so on, but this is really very important. Thank you.
Yeah, thank you.
Okay, are there other questions? No. Okay, so I think we'll stop here. I thank you very, very much, Atalay, for your presentation. And I also thank everybody who came here this afternoon or this morning, depending on where you are. So thank you very much.
Thank you. Thank you, Catherine.
Thank you, Catherine.
Bye.
Bye-bye.
Bye.
Bye-bye.